Hello everyone, I hope you're doing well. So in this video, we're going to discuss the first three problems of Codeforces Educational Round 146, which was rated for Division 2. So this contest overall, I felt was a bit tricky, and the first two questions were maths heavy. And you can see the submissions, the second question has less submissions than the third questions. So and overall both B and C have very few submissions as compared to a normal contest. So this contest was a bit on the weird side, and even I made a few wrong submissions on both A and B problems. Not a few, but many wrong submissions. So let us quickly discuss the problems now. Now the first problem is that there are two types of coins having denominations of 2 and k bureaus, right? And we have to find whether we can form a total amount of n with them. So it has to form this type of equation where 2x plus ky is satisfied is equals to n is satisfied, where x and y can be any positive integers, right? So there are actually a couple of ways to solve this problem, but let us first discuss the sample test case that has been given to us. So starting from the value of n is 5 and the value of k is 3, right? I can take one coin of this particular type and one coin of value 2, and the total number of bureaus will be 5, right? So in this case the answer will be yes. Again, for the second case, n is equals to 6 and k is equals to 1. I can form like the 6 total amount by two ways, or I can take either the bureau with one value 6 times, so it will be 6 into 1 equals to 6, or I can take the bureau of value 2 3 times, it will be 6, or I can use a combination of these two, right? So for this also the answer will be yes. Now the next is n is equals to 7 and k is equals to 4. So if this is the question, now you would observe that there is no way to form n is equals to 7. The answer would be no, and this case also the answer is yes. As we have discussed in the previous phase, you can use any of the ways, and one of the ways would be if n is equals to 8 and k is equals to also 8, we can take one coin of this particular type, right? So the answer is yes for this case also. Now how do we find a general case where we can find the answer for n, some value of n and some value of k? So you would observe if the value of n is like an even number like 8, right? So it is always possible to form the answer. When n is even, it is always possible to form the answer. Why? Because we already have a bureau of 2 value, so we can take, like, if n is even, then it must be some value m multiplied by 2, right? So this should be equals to n, right? And I can take any amount of these m bureaus because I have a bureau with value 2, so I can form any even number. So that case first is solved when case 1 is when n is even, right? In this particular case, answer always exists. Answer always exists. So the answer will be 1 or yes, right? Now the second case is when n is odd, right? N is odd. How we can solve this particular case? So when the value of n is odd, then what happens is our answer will depend on k, right? So if k is also odd, right? If k is also odd, that means k and 1 is equals to 1, like you can call it anyway. So if k is odd, what happens is we already have an even number and we have an odd number. If we add these two numbers, we will get the next odd number. So it is 3. Then we can again add 2, we will get 5. Then we can again add 2, we will get 7, then 9. Right? It will keep on going this. So we can form all odd numbers like this. So if n is odd and k is also odd, the answer would be yes. Otherwise, if k is even, the answer would be no. Because if k is even, then 2 is already even and k is also even, right? And the sum of two even numbers can never be odd, so the answer will be no in this case. These are all the test cases that you have to discuss. Now there is one very important thing, although that is not required to solve this question, but I'm just discussing. So any equation of this particular type, ax plus by is equals to c, are called linear Diophantine equations, right? So in this case, a could be like 2 and b could be k, right, is equal to c, right? So these are called linear Diophantine equations, and the given equation was of this particular form. Now for this particular condition to have like real values of x and y, there is a condition that the number c should be a multiple of, like m is any integer here, a multiple of gcd of 2 comma k in this case, or in general case it should be a multiple of gcd of a comma b, right? So c should be a multiple of 2 comma k in this particular case. So what I can do is I can just check if c mod gcd of 2 comma k is equals to 0, then the answer would be yes, otherwise the answer would be no, right? So I just have to check this particular condition. If c mod gcd of 2 comma k is equals to 0, then the answer is yes, otherwise the answer is no. So I also tested this solution and it works. So you can be like this assured that this particular solution also works and this approach is correct, right? So you can use any of the approaches, and there is like not much to show in the code. So I've just checked whether like n is divisible by gcd of 2 comma k or not, right? If it is, if it leaves a remainder, the answer would be no, otherwise the answer would be yes. So let us move on to the second question. So the second question actually had less submission than the third question, and you can also see I made a lot of wrong submissions on this particular question. So let us quickly discuss this particular problem. So this says that we we can jump to a cell x plus m and y plus m, right? So if you are at x comma y, you can go to x plus m comma y or x comma y plus m, right? Or the third operation is you can increase the value of m by 1, right? So you will see that, you will observe that all the values are only incremented, we cannot decrement them, right? So initially we are at cell 0 and we want to reach cell x comma y. We have to tell what are the minimum number of steps such that we can reach the cell a comma b following these particular operations, and in one operation we can perform like one of these steps. So like this question is very interesting, and you'll have to make a couple of observations. So the first observation is that, for example, if you are at 1, the value of m is 1 and you want to reach 100, right? So let us just take some value m 1. For m is equals to 1, right, you will have to make 100 number of operations, that is you can just keep on going to the right by 1 unit, right? So after 100 operations you will reach this particular value from 0, right? So this was initially 0 and the value of m is 1. Now if you want to take m is equals to 2, then you will have to make one operation just to increment the value of m by 1, and the other 50 operations will be required to reach 100. If you want to take m is equals to 3, then you will have to make two operations just to make the value of m is equals to 3, right? Now you will observe that even if this distance 100 is not divisible by 3, then also we can form our answer, and I'll discuss how. So you can always take 33 number of steps. So 33 into 3 is equals to 99, right? You would be left with only one step in this case. So you could have taken this particular step initially when m was equals to 1, right? So the total answer would be 2 plus 33 plus 1, right? Or this 33 plus 1 can also be written as 100 divided by 33, the CL value of this, right? Now for let us take some other value such that this particular value of 100 is not divisible by m. So for m is equals to 6, let us see what happens. So first of all, you would need to make 5 operations just to make the value of m is equals to 6, right? Now you can make 16 complete operations and the value of 16 into 6 would be 96, right? You are still left with 4. Now how do you cover this? Now when you were making m is equals to 6, you would have first taken it to be 1, then taken it to be 2, then 3, then 4. As and when the value of m was 4, you could have moved 4 units ahead, right? Then the total value left would be 100 minus 4, that is 96. And when the value of m is equals to 6, you can just make 16 moves to reach this particular value, right? So the answer should be still plus 1, and it is also equals to 100 divided by 60 and the C value of this. So you always observe whenever the value m is not dividing the actual distance, that is d, then we just have to add plus 1, or we can just directly take the value, the C value of this particular thing, right? So this is the first observation. that you can always form or you can always reach the distance d with any m, even if m is not a divisor of t, right? Now the second observation is, once you reach root d distance, that is root 100 in this case, that is 10, right? So for 10, m is equals to 10, you would require 9 operations just to make it equals m equals to 10, and then you would require 10 operations. So the total number of operations is 19. As soon as you start going beyond m is equals to 10, then what happens is, let me just show you a case where m is equals to 15, right? So you would need 14 operations to make it 15, then you would need 6 operations, right? You would need 6 operations just to make 15 into 6 equals to 90, and then again one operation, because the seal value of 100 divided by 15 is 7, right? So you would need to do this. Now in this case the answer is 21. You would observe, as soon as you start going beyond the value of root n, you will eventually increase your total answer, and this is not optimal. So we will only go till root n, right? Now this is the value of a and b is 10 raised to the power 9. A safe value can be around 1e5 or 10 raised to the power 5, right? This is a safe value to take for root n, right? So what we can do is, for all values from 1 to 10 raised to the power 5, for all values of m from 1 to 10 raised to the power 5, we can check which of them gives us the best answer for both a and b, right? So this is exactly what we are going to do in the code. So this is the code for the second problem. So what I've done is, I've taken the maximum value to be 10 raised to the power 5, and I've initialized my answer with infinity. Now I just run a loop from 1 till less than equals to the maximum value, and for the x coordinate, the value would be the seal value of, so let me just write it for you. So this actually calculates the seal value of x by I. So this is one method of doing the seal value, right? What you can do is, seal value of x by I is always equals to this particular value, x plus I minus 1 divided by I, right? So you can do it for any general case. Seal value of a by b is equals to a plus b minus 1 divided by b, right? So this equation is correct. If you do it in this way, you are always dealing with integers and there is no chance of any precision error, right? So that is why I prefer this method, and this way you can calculate the value of seal of x by I. Similarly, you can calculate the value of seal of y by I, right? So these would be the number of steps required to go from 0 to x and 0 to y in with a step of m, right? Now to reach a step of m or a step of I, in this case I have taken it I. If to reach a step of I, you would need I minus 1 operations, then you will need xx number of operations to reach x, and then yy number of operations to reach y. So you would add all of these, and the answer would be minimum of answer comma this particular value, and at the end we can just print the answer. So this would be the solution for the second problem. Now moving on to the third problem. So the third problem was actually like easier than the second problem, and this is like just a greedy problem, and you can do it with a simple sorting technique. So this particular problem says that these are some tasks, or let's say these are some values that we need to find, right? So we just explain you with the diagram. So if this is the sample test case, right? So initially we have some tasks like 1, 2, 3, 4, 5, 6, 7, right? So these are some colored balls, and what we have to do is, the first ball is called 8 times, the second ball is called 6 times, the third ball is called 4, and 4, and 4, 1, 7. So let's say that these are balls, right? And these are some like frequencies. So that means the first ball is called 8 times, the second ball is called 6 times, the third ball is called 4 times, fourth ball is called 4 times, and so on, right? Now there are two robots, the robot 1, and let me write it as capital. So the robot 1 and robot 2. Robot 1 takes 3 seconds and robot 2 takes 1 second to scan any ball, right? So this particular information that has been given to us in the input says that ball 1 needs to be scanned 8 times, ball 2 needs to be scanned 6 times, right? So if robot 1 can scan a ball in 3 seconds and robot 2 can scan a ball in 1 second, we have to like form an optimal arrangement and give a list to robot 1 as well as robot 2 such that they complete the scans in minimum time, right? So we have to give a list to robot 1, like I can give it 4 and then 3 and then 2, right? So every time it needs to scan 2, it will first scan 4, then scan 3, then scan 2, and after it has scanned 2, it will be counted as a successful scan, right? So I have to repeat this 6 times for 2. So considering all of these things, I have to form an optimal list for both robot 1 and robot 2, right? So the very first idea is that we need the number or the balls with the highest frequency to be calculated in minimum time, right? So if ball 1 is required the most number of times, I would want that the time required to access this particular ball is the minimum among all the other balls, right? So let me first arrange them in decreasing order of their frequency. So the first ball would be 1 and the second ball would be 7, the third ball would be 2, then 3 4 5 can be in any order, so 3 4 5 and 6, right? So these are the balls sorted in decreasing order of the frequencies or in decreasing order of the number of excess times, right? So what happens is the first ball is required the most number of times, so I would always want that the time required to reach this particular ball or to scan this particular ball is minimum, right? So how do I assign these to robot 1 and robot 2? I see that robot 2 currently takes 1 second to scan any ball. So what I will do is I'll assign the first ball to robot 2, right? Now what happens is I have the second ball which is 7. Now I have two options. The first option is to assign to robot 1 and the second option is to assign to robot 2. Robot 1 will take 3 seconds, but robot 2 will take 2 seconds. How will it take 2 seconds? So if I place it here, then what happens is it will first scan the first ball, it will take 1 second, then scan the second ball, then the total time will be 2 seconds, right? Now I have placed first the first and the second ball. Now the third ball is ball 2. Where do I place it? Now for the first robot it will take 3 seconds, and for the second robot it will also take 3 seconds because it will have to scan the first ball, then the second ball, then the third ball. So I can place it anywhere. So let me just place it here, right? So in this case it doesn't matter where you place it, you can place it anywhere, right? So now the first robot will still take 3 seconds, but the second robot will take 4 seconds, right? So this is not optimal. So we would try that the ball 3 should be given to robot 1, right? Once I have assigned this, now I move on to the next ball. So now since there is already one ball with robot 1, now it will for it to complete the second scan or scan for the second ball, it will take 6 seconds. So if I already have a ball here and I place another ball X here, then the total scan time would be 6 seconds to scan the ball X. I don't want it because the scan time is still 4 here, so I can place it here. So the next ball here is 4, right? Once I have placed it, the scan time for the next ball would be 5. It is still smaller than 6, so I can place the ball 5 here, right? Now the scan time, if there are already 5 balls here and I place one more ball here X, right? So the total scan time would be 6 seconds. Now no matter where I place it, the total scan time for that particular ball would still be 6 seconds, so I can place it anywhere, right? So let me just place it with the first robot. So here we have the last ball 6. So this is the list or the output that we have to give. We'll have to first output the size of the list for robot 1, that is 2, and then the actual list, that is 3 and 6. Then we have to output the size for the second robot, that is 5, and then the balls of that particular list. So this is how we have to output, right? So the answer can be different in certain cases, like there are multiple possible answers for this particular question, but this is the way that you will be solving this particular problem. So now let us have a look at the code. What do we do in the code? We just take 3 integers n, x and y, right? So x is the time taken by the first robot and y is the time taken by the second robot. Now I just initialize a pair of a vector of pairs in comma 8, and I just input the value of the first in the first element of the pair, and I just save the index in the second element of the pair. Now I just sort it like by the default order. So it will be sorted in increasing order by the first value. So I just reverse it because I wanted the first value to be in decreasing order. Now I create two vectors A and B which will be storing the final output, and I just initialize my index from 0 and I'm just running a simple for loop till less than n. Now I have taken this variable OK, but it actually tells which is the correct place to keep the ball. So I can also write it first, then it will be much better. So if the first is true, that means I can place the ball in the first vector, otherwise I have to place it in the second vector. How do I check it? So I just check it if size of a into x, a plus 1 into x. So what is actually this particular value? Size of a is the number of balls that are currently in a, and plus 1 because I also have to include the current ball, and I multiply it by the scan time of robot 1. So this is the total scan time that it will need, right? Similarly, size of b plus 1 into y. So this is the total scan time that the second robot will need. So if the first value is less than equal to the second value, that means I can push it into the first list. So if first is true, then I can push it into the a vector a, otherwise I push it into the second vector. And while the time of pushing, I just do index plus plus so that I don't have to increase it later on, right? So this is post increment. Now after all of this is done, I can just print the size of the vector a and just print the whole vector, and then print the size of vector b and just print the whole vector. So this was all about today's contest, and I hope that you guys were able to understand the solutions. If you guys did, then you can show your appreciation by dropping a like on this video, and don't forget to subscribe to this channel and share this channel with your friends. So till the next video drops, keep coding, stay safe, bye bye.